Hi class, this is lesson 7-6, sine and cosine ratios. So let's go through these notes. It says sine and cosine ratios are trigonometric ratios for acute angles that involve the lengths of a leg and the hypotenuse of a right triangle. So again, we had these abbreviations. We had an abbreviation yesterday for tangent. Today we're going to have sine. We're going to put SIN for sine. For cosine, we're going to put COS. Hypotenuse, we're just going to use HYP for hypotenuse. Okay, so here's our definitions for sine and cosine. The sine of an angle A is the length of the leg opposite of angle A over the length of the hypotenuse. So here's my angle A right here. The leg opposite it would be right here. That is the leg BC. And the hypotenuse would be right here. And that is AC. And we're talking about the lengths, so we're just going to use BC with no line above it, and then AC. So I remember as the sine of my angle equals opposite over hypotenuse. Or yesterday I told you to remember TOA, T-O-A, TOA, tangent is opposite over adjacent. Here we remember SO, S-O-H, sine is opposite over hypotenuse. For cosine, let's look at the cosine one. So the cosine of an angle A is the length of the leg adjacent to the angle divided by the length of the hypotenuse. So if this is my angle A, the leg adjacent would be right here, so we're going to do this length over the hypotenuse, this length. So it would be AB, length AB over length AC. And we can also remember cosine of any angle, so theta is any angle, equals adjacent over hypotenuse. Or we can remember cosine is adjacent over hypotenuse. So what I'm going to ask you to start remembering, we do it like this. So, TOA. So when I say we're going to use TOA, that's what I mean. And that means sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent is opposite over adjacent. And it's just a little word game to help us remember this. So let's look at our first example. It says, find the sine of U and the sine of W. Write each answer as a fraction and as a decimal. So let's do the sine of U first. So let's identify where angle U is. Right here's my angle, my theta that I'm talking about. So if that's my angle, my hypotenuse is right here. My side next to it is my adjacent. And my side across from it is my opposite. So sine uses opposite over hypotenuse. So my opposite side for angle U is 16. My hypotenuse is 34. And the directions say write each answer as a fraction, and we're going to simplify that fraction, and as a decimal. So 16 over 34 reduces to 8 over 17. This would be my fraction form. And if you put that into your calculator, it's about equal to 47 hundredths. This would be your decimal form. Let's look at W. We now want to find the sine of W. So we need to identify where W is on our picture, and W is right here. And if I label my four sides according to W, well, my hypotenuse is still the same. The side length 16, VW, that is now my adjacent, and across from it, the side of length 30 is my opposite. So sine is opposite over hypotenuse, so the opposite side from angle W is 30, and the hypotenuse is 34. So if we reduce 30 over 34, that gives us 15 over 17 as a reduced fraction. So there's my answer in fraction form, and we often just keep the fraction form of these. Usually, especially when you move into Algebra 2, you'll just keep your answer as a fraction. If you change it to a decimal, though, you would get 0.88 or 88 hundredths. All right, let's try this next problem. This one's an on-your-own problem. So if you haven't tried it yet, it would be a good idea to pause the video and try it on your own. It says find the sine of B and the sine of C. So let's start with the sine of B. So the sine of an angle, and we're using B here, equals so sine is opposite over hypotenuse. So I'm going to identify angle B on my picture. It's right here, and I'm going to label my three sides according to that. My hypotenuse is right here. That's the 29. It's across from my right angle. Right next to angle B is my adjacent side, and across from angle B is my opposite side. So I want the opposite side over the hypotenuse. So the opposite is length 21. My hypotenuse is length 29. Well, 21 over 29 doesn't reduce, so this is my fraction form. And if you put it in your calculator and reduce it as a decimal, it's 72 hundredths. So here's your answer as a decimal. Now let's find the sine of angle C. And sine of any angle is the opposite over the hypotenuse. So angle C on my picture is right here. I'm going to highlight it in blue. And I'm going to label my opposite, adjacent, and hypotenuse when the angle that I'm looking at is angle C. My hypotenuse stays exactly the same, but now the length of 21 is my adjacent side. The length of 20 is my opposite side. I want for sine of C the opposite over the hypotenuse. My opposite side has a length of 20. My adjacent side, my hypotenuse has a length of 29. 20 over 29 does not reduce, so this is my fraction form for the sine of C. And if you put it in your calculator and reduce it, you find that that's about 69 hundredths. So there's your decimal form. All right, let's now use the cosine ratios here. So it says, for this next example, find the cosine ratio, find cosine of S and the cosine of R. Write each answer as a fraction and as a decimal. So we're going to start with the cosine of S. So we're going to identify S as our angle. So I'm going to write that, mark that right there. I'm going to put my H for my hypotenuse. So across from my right angle is the side 53. Right next to my angle S is 45, so that's my adjacent side. And across from my angle S is length 28, that's my opposite side. Cosine, remember, toa, A and H, adjacent over hypotenuse. So my adjacent side has a length of 45. My hypotenuse has a length of 53. And 45 over 53 does not reduce. That's a reduced form of that fraction, so that's my answer in fraction form, which we will want to keep that. If you do want to round it, you would have 85 hundredths. My next problem wants me to find the cosine of angle R. So I'm going to identify R here in green and label my hypotenuse, adjacent, and opposite according to angle R. So my hypotenuse is still the side of length 53. Your hypotenuse is always the same. Across from angle R is the side of length 45. That's now my opposite side. And the side of length 28 is now my adjacent side because it's right next to angle R. So for cosine, I want adjacent over hypotenuse. So my adjacent is length 28. My hypotenuse is length 53. And 28 over 53 doesn't reduce, so there's my reduced form of my fraction. And then as a decimal, that would be about 53 hundredths. All right, let's look at the next side of this page. Okay, this one says find the cosine of B and the cosine C. This is an on your own. It's just like the one we just did. We want to write each answer as a fraction and as a decimal. So we'll start with the cosine of B. And I'm going to say, so C-A-H, cosine is adjacent over hypotenuse. So C-A-H, adjacent over hypotenuse. And in order to figure out my adjacent and hypotenuse, I need to label where my angle B is. That's right here. It's the angle I'm looking at. Across from my right angle would be my hypotenuse. So that's my hypotenuse. Right next to angle B is my adjacent side. And across from angle B is my opposite side. So I just want the adjacent over the hypotenuse. That's going to be 20 over 29. And 20 over 29 doesn't reduce, so this is my fraction form of it. If you put it in your calculator and simplify, you'll find that that's 69 hundredths. Let's do the second part to this problem. The second part wants us to find cosine of C. And since we're doing cosine again, that's going to be adjacent over hypotenuse. Excuse me, I sneezed. So adjacent over hypotenuse. Now let's label our angle on our picture. Here's angle C. My hypotenuse is still the same side. My adjacent side is right next to my angle C, and my opposite side is now across from my angle C. So notice my adjacent and my opposite switched places. So for angle C, my adjacent side is length 21. My hypotenuse is length 29. And 21 over 29 doesn't reduce, so this is my fraction. And if you put it in your calculator and change it to a decimal, you would find that that's 72 hundredths. All right, let's use a trig ratio to find the hypotenuse here. So looking at the question, it says you walk from one corner of a basketball court to the opposite corner. Write and solve a proportion. There's my directions right there, so I'm going to highlight it. Write and solve a proportion using a trigonometric ratio. There's a key thing. We want a trig ratio, so sine, cosine, or tangent, to approximate the distance of the walk. So it says we're walk from one side of the basketball court to the opposite corner. So we're walking this path right here. We want to find x. Well, I'm going to use, I see that I've got this angle right here that's 62 degrees, so I'm going to use this side. And this is a right triangle, so I know that I can use trig ratios. I only use my trig ratios with right triangles. And if this is my theta, my angle that I know, I'm going to label my sides according to that. So my hypotenuse is right here. It's across from my right angle. The side across from my angle is my opposite. So I know my opposite and my hypotenuse. My adjacent is this side down here, but I don't know what that is. So I've got two pieces of information. I'm actually going to write a problem, and I'm going to ignore this adjacent side. I'm going to write a problem that uses my opposite, because I know that, and my hypotenuse, and it uses this angle right here. So if you ask yourself what uses opposite and hypotenuse, and you think, I'll write it down instead of just thinking it. If I say so, ka, toa, to help remember sine, cosine, and tangent, you can see by writing it out, doesn't sine use opposite and hypotenuse? So we'll say the sine of our angle, which is 62 degrees, we now have the angle, equals opposite, which is 94 feet, over my hypotenuse, which is x. Now it wanted me to write and solve a proportion. I only have one side of my problem being a fraction now, so I can put sine of 62 over 1. Now I have a proportion, and I can cross multiply. So I've got 1 times 94, so that's 94 equals sine of 62 times x, so that's x times the sine of 62 degrees. And if I'm trying to solve for x, I need to move that sign. Since they're multiplied, I'll divide by the sine of 62 degrees. And I have to do that to both sides to get my angle x alone. Or not my angle, my side length x alone. So those cancel. I now have x equals 94 divided by the sine of 62 degrees. And if you put that in your calculator, this will be x is about equal to 106.46, and we're talking about a distance walked here, so a length. My units would be feet. And that's our answer, 106 and 46 hundredths feet. The next problem says use the cosine ratio, it's telling me right there, cosine ratio, to approximate the width of the basketball court, and so that means across the baseline. So I'm going to calculate the width of the basketball court. So I'm going to find this length, oops, I'm going to find this length right here. So, and it says use the cosine ratio. So cosine, the cosine of an angle equals adjacent over hypotenuse. So I know my angle, it's 62 degrees, so we can say the cosine of 62 degrees equals, I'm trying to find my adjacent side really. If I'm looking for the length across the baseline, didn't we identify it right here? That was our adjacent side. So that's our unknown, our x over, we found the hypotenuse up above, 106 and 46 hundredths. So my problem's set up now. Now I just need to solve this. So I'll turn it into a fraction by putting this over 1, and I'll cross multiply. 1 times x is x. And multiply these two, I have 106 and 46 hundredths times the cosine of 62 degrees. Now since this is all stuff that we know, you can put it right into your calculator just like that. So if you put 106 and 46 hundredths times the cosine of 62 degrees, you'll find that your answer is about, so I'm going to round it, 49.98, and that would be in feet. So there is my answer. All right here it says find a leg or hypotenuse using an angle of depression or an angle of elevation. So these are new words. You haven't heard these words before. So the angle of depression is an angle between the line of sight and looking down. That's okay, looking down. So if you were looking straight forward, okay, looking straight ahead, and you moved your head so that you were looking down, this angle right here would be your angle of depression. So that's looking down. An angle of elevation would be the angle between the line of sight and looking up. So if you're looking straight forward and then you tilt your head upward, so you're looking up a little ways, this amount that you're looking up, that you tilted your head upward, that's called your angle of elevation. So let's try an example with these. It says you're at the top of a roller coaster 100 feet above the ground. It's probably a key piece, so I'm going to underline it, 100 feet above the ground. The angle of depression is 44 degrees, okay? 44 degrees, key thing. Also, angle of depression is a key thing. About how far do you ride down the hill? There's my question. How far do you ride down the hill? So let's look at our picture and highlight it a little bit. So we're at the top of the roller coaster, and it's 100 feet above the ground, and that tells us this right here. The angle of depression is 44 degrees, so it gives me my angle of depression right here. How far do you ride down the hill? So this is what we're looking for. We're going to use sine, cosine, or tangent. We're going to use one of those. So let's label our triangle according to my angle of 44. So if this is the angle I'm looking at, here would be my right angle, so across from it would be my hypotenuse. So x is your hypotenuse. And this is the side across from your 44-degree angle. That would be your opposite side. So I've got hypotenuse, and I've got the opposite side. So if we think so, ka, toa, what uses opposite and hypotenuse? Well, that's my sine. So I can say the sine of an angle equals opposite over hypotenuse. Well, I know what my angle is, so I can say sine of 44 degrees equals opposite, which is 100, over hypotenuse, which is x. I can now turn this into a proportion. So I can put this over 1 and cross multiply. 1 times 100 is 100 equals, cross multiply here, you have sine 44 degrees times x. And I want to get that x alone, so I need to move the sine of 44 to the other side. And I'll do that by dividing by the sine of 44 degrees. So those cancel out. My x is now alone. So I have x equals 100 divided by the sine of 44. And if you put that into your calculator, you'll find that it's about, so I'm going to use my squiggly equal signs, 143.96, so 143 96 hundredths, and my unit would be feet. Let's look at the next problem here. It says a railroad crossing arm that is 20 feet long, so that's a key piece of information, is stuck at an angle of elevation of 35 degrees. That's another key piece. Find the lengths of x and y. That's directions, so I'm going to highlight that. So I'm guessing I'm going to have to use one of my things, sine, cosine, or tangent, one of my trig functions, to find the lengths of the unknown legs. So looking at my picture, here's my angle, that's 35 degrees. My hypotenuse is right here, that's 20. Labeling my two legs, the y is right next to the angle of 35, so that's adjacent. X is across from it, so this is opposite. Now I need to find both x and y. So I'm going to have to set up two separate proportions. I'm going to have to use one with opposite and hypotenuse, and I'm going to have to use the other one with adjacent and hypotenuse. So looking here, opposite and hypotenuse is sine, adjacent and hypotenuse is cosine. So I'm going to have to use both of those to find my x and my y. So let's find x first. Okay? So to find x, we're going to find x first. We're going to set up a problem that has the opposite and the hypotenuse. So we'll say the sine of my angle is 35 degrees equals opposite, which is x, over hypotenuse, which is 20. If I'm going to find y, then I'm going to have to use y and my hypotenuse. So that would be the cosine. So we would say the cosine of 35 degrees equals adjacent, which is y, over hypotenuse, which is 20. So see how I set up two different trig functions here, two different trig problems, so that I could find both of those? Now let's just solve them separately. So for my find x, I'm going to put my sine over y, and I'm going to cross multiply. 1 times x is just x, equals, multiply here, I have 20 times the sine of 35 degrees. And you can just put that right into your calculator, which you should try to make sure you get the right answer. And you'll find, you should get, that x is about equal to, and that's 11 and 47 hundredths, and my unit here would be feet. Let's solve our cosine ratio. So I'll put the cosine of 35 over 1, and I'm going to cross multiply again. 1 times y is y, equals 20 times the cosine of 35 degrees. And I can put those right into my calculator as well. So y is about equal to, if you put those right into your calculator, you'll get 16 and 38 hundredths, and my unit there would be feet. So for this problem, I'm using both the sine and the cosine ratios to find my two unknown sides. All right, we got one more side. These are a little longer notes, so let's look at our last page here. All right, it says refer back to example A above. Suppose the angle of depression is 72 degrees. How far would you ride down the hill? So I'm going to draw the picture. A is the one where we're talking about the ride. Okay, so here's my ride. Okay. And in this picture, we talked about the height to the ground being 100 feet. And now it says my angle of depression is going to be 72 degrees. So this angle is now going to be 72 degrees. How far would you ride down the hill? Well, that's my x right there. So I set my problem up. My angle is 72 degrees. So my hypotenuse would be my x. So I'm going to put my hypotenuse right here. And the 100 feet is across from the angle 72 degrees, so that's my opposite side. So if we say what uses opposite and hypotenuse, well, that's sine. So we can say the sine of an angle equals opposite over hypotenuse. My angle here is 72 degrees, so we say the sine of 72 degrees equals opposite, which is 100, over hypotenuse is x. We've now set up a trig problem. We need to change it into a proportion, or to a ratio, proportion, I was right the first time. Cross multiply, so I'll put that over 1. 1 times 100 is 100, equals, multiply here, so it equals x times the sine of 72 degrees. And if I want my x all alone, I'm going to have to divide by the sine of 72 degrees on both sides. That will make those signs on the right side cancel out and leaves me x all alone. So x equals, I'll just rewrite it once here, 100 divided by the sine of 72 degrees. So put this into your calculator and you'll find that x is about equal to 105 and 15/100ths, and my unit there was feet. The next one says refer back to example B. So this is the one where I had this little thing that was stuck up in the air. I had my crossing guard, I think it was called, my crossing arm, my railroad crossing arm that was stuck up in the air. And then it's stuck at an angle of elevation now of 40 degrees. And we know the length is 20 feet of our crossing arm. And it says, what are the new lengths of x and y? So here's my right angle. Y is down here and x is on this side. So let's label hypotenuse, opposite, and adjacent. So if this is my angle, that's 40. 20 would be my hypotenuse. Y is still going to be my adjacent side, and x is still my opposite side. So once again, if we want to find both our opposite and adjacent, we're going to have to find two different proportions for this. So I'm going to start by finding my x and this side. Those are the two that I need to use. That's opposite and hypotenuse. So I'm going to use the sine in order to find my length x. So I'm going to say the sine of 40 degrees equals opposite, which is x, over hypotenuse, which is 20. If I change that into a ratio, put it over 1, actually a proportion, I keep mixing up my words there, I can cross multiply. 1 times x is x, equals, cross multiply here, you have 20 times the sine of 40 degrees. So x is about equal to, if you put that into your calculator, 12 and 86/100ths. And my unit there would be feet. Let's try the other problem. Let's find our y. So if I want to find y, y is my adjacent side, and I'm also going to use hypotenuse. So cosine uses adjacent over hypotenuse. So let's set up a cosine problem. So we'll say the cosine of 40 degrees equals adjacent, which is y, over hypotenuse, which is 20. So once again, I can turn my problem into two fractions, and I can cross multiply. 1 times y is y, equals, cross multiply here, you have 20 times the cosine of 40 degrees. So y is about equal to, if you put that into your calculator, you'll find it's 15 and 32/100ths, and my unit there would be feet as well. So let's just do a quick review here to help us remember what sine, cosine, and tangent all mean. We use SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. I have a hard time writing hypotenuse. Tangent is my opposite over my adjacent. And if you have a hard time remembering that, just write it down repeatedly. So, ka, toa. Write it down over and over and over again until you get that stuck in your head, because you will need to use it for both Geo and for Algebra 2. And have a great night.